Okay, in this lecture we're going to learn how to solve rational polynomial equations. Now we've done something similar when we simplified polynomial expressions, but now we have an equation. We're going to have an equal to sign, and we're going to actually solve for x. We're going to find the value of x that makes it true. We cannot do that if we don't have an equal to sign. So previously all we've done is simplify. That just means change the way the expression looks. Put it in a simpler, make it look simpler. Okay, so this is what we're going to do to solve a rational equation. What we're going to do is we're going to have to find the least common denominator of all the denominators. Now when I find an LCD of all the denominators, I know that each denominator has to divide evenly into the LCD. So then I'm going to multiply both sides by that LCD, both complete signs, and so you know that if a denominator divides evenly into the LCD, that the denominator is going to go away. And then lastly, we're going to check for extraneous solutions. Now here are some big differences between solving and simplifying. To solve, we're going to have an equal to sign. When we simplify, there's not going to be one. To solve, we're going to find the value of x that makes it true. In simplifying, we cannot do that because it doesn't have an equal to sign. To solve, we're going to multiply both sides of the equation by the LCD. That's not going to be like when we simplify, when we have to multiply a term by 1. Here we're going to multiply a term by the whole side by some value, and it does not have to be 1. And it's okay as long as we do that same thing to the other side. Now when we simplify, of course, we know that we always have to have something by 1. So, you know, if I had x all over 3, and I wanted to change, say, I wanted to take it times 4 over 4, I have 4x over 12. Well, I haven't really changed any values. I've just changed the way it looks by multiplying by 1. And that's all we can do when we simplify. Okay, so let's see how this works. And here's just an example, and what we're going to do here is we are going to find an LCD. Now the LCD, I have an x, and I have a 2, and I have an x. So by now we should be able to recognize that LCD is going to be 2x. Now what I'm going to do is I'm going to multiply both sides by, both complete sides, by 2x. So okay, so when 2x multiplies to the first term, I'm going to have 2x times 4 over x. And then when it multiplies to the second term, I'm going to have 2x times 5 over 2. And now when this 2x multiplies by the 11, I'll have 2x times a minus 11 over x. And you can see that these denominators are going to divide into the LCD and go away. So this x will divide into that x, or cancel that x, and I'll have 2 times 4 is 8. Now this 2 will multiply, or will cancel into the 2 in the LCD, and it's going to be equal to 5x. And now then on the last one, I'm going to have this x will divide into that x, or will cancel that x, and I'll have equal to minus 22. Okay, so now what I'm going to do is I'm going to subtract 8 from both sides. So I have 5x is equal to 30, negative 30. So x is equal to negative 6. Now we need to check that. So let's go ahead and do that. So putting a negative 6 in there, I'm going to have I've got 4 all over negative 6 plus 5 all over 2 is equal to a negative 11 over 6. So changing this denominator, or this fraction, into a common denominator, I'm going to have, actually, this last number should have been when I plugged in -6 here for the original equation, that would make that a positive. So anyway, getting back to the check, if I need to have a -6 as a denominator, so I'm going to take this second fraction by a -3. So I'm going to have 4 all over a -6. And if I take that times a -3, I'll have a -15 all over -6. Is that equal to 11 over 6? I'm going to have 4 minus 15. That's going to be a -11 all over -6. Is that equal to 11 over 6? Yes, it is. 11 over 6, both negatives. That would be a positive 11 over 6. That's going to check. So that's a good answer. Okay, the next example. We have a denominator of x minus 2 and a denominator of x minus 2. So the LCD of this is going to be x minus 2. Okay, so let's multiply both sides by x minus 2. So on the first side, I'll have 5x. And then I'm going to have x minus 2 times the entire side. Okay, so if an x minus 2 multiplies in here, this x minus 2 will cancel into that one, giving me 5x. Okay, so multiplying x minus 2 to the 7, I'm going to have 7x minus 14. And this x minus 2, of course, then this thing be plus. There's my plus. This x minus 2 would multiply by the 10. Actually, x minus 2 is going to multiply by the 10 over x minus 2, and the x minus 2's will cancel, just giving me 10. So I'm going to have 5x is equal to 7x minus 14 plus 10. 5x is equal to 7x minus 14 plus 10 would be minus 4. So I'm going to have subtracting 7x from both sides. I'm going to get a minus 2x is equal to minus 4. So x is equal to 2. Let's check that. So I have 5x all over x minus 2. Uh-oh. Can you see what's going to happen? If x is 2, then when I substitute it into this equation, 2 minus 2 is going to be 0. That's going to give me 0 in the denominator, so this is an extraneous solution. And since 2 is the only answer I got, this particular problem would have no solution. Okay, let's work another example. For this particular problem, we have two denominators. One is x plus 1. One is x squared minus 1. So let's work on the denominators and see what our LCD is going to be. So for x plus 1, so for x plus 1, and then we have x squared minus 1, which factors into x plus 1 times x minus 1. So the LCD of this, as you can see, I have x plus 1 and x plus 1 down there. I have an x plus 1 in the LCD, and then x minus 1. Okay, so let's go ahead and multiply both sides by the LCD. So for the first one, I have x minus 1 and x plus 1. And that's going to multiply by 4x plus 1 all over x plus 1. And the next side, I'm going to have x minus 1 times x plus 1, multiplying by this whole side. That's going to be 12 all over x squared minus 1, which of course is x plus 1, x minus 1, plus 3. So multiplying x minus 1, x plus 1 into this first term, the x plus 1 will cancel with this x plus 1, giving me x minus 1 times 4x plus 1. Now on the other side, x squared minus 1 is the same as these two multiplied together, so when this multiplies by the first term, all I'm going to have is 12. And then I'm going to have plus 3, and there's no denominator, so I'm going to have x minus 1, x plus 1. Okay, so let's go ahead and simplify. This is going to be x times 4x, that's 4x squared. Then I'm going to have plus x minus 4x and minus 1. The other side will have 12 and plus 3 times x squared minus 1. So 4x squared minus 3x minus 1 is equal to 12 plus 3x squared minus 3. 4x squared minus 3x minus 1 is equal to 3x squared minus 9. So I have 4x squared minus 3x, that'd be plus 9 because that's a 12, so that'd be plus 9. Now I will subtract 9 from both sides, that gives me minus 10. And let's see if we can factor that. It's going to be with AC middle. Actually, I didn't subtract my 3x squared, so this is not going to be 4x squared. This 4x squared minus the 3x squared is going to be just x squared. So let me go ahead and get rid of the 4. Okay, so that looks better. So actually, this is going to be easier to factor now. This is going to be x minus 5, x plus 2 equal to 0. So I'm going to have x is equal to 5, and x is equal to negative 2. So I need to check those, so let's check 5. Okay, so if I put 5 in there, I've got 4 times 5 plus 1 all over 5 plus 1 is equal to 12 all over 5 squared, that's 25, 12 over 24, plus 3. So I've got 21 all over 26, over 6 is equal to 1/2 plus 3. This would be 6 will divide in, that would be 3 1/2. So I have 3 1/2. So that checks. Let's check 2. So I've got 4 times 2 plus 1 over 2 plus 1 would be equal to 12. And now if I have 2 squared minus 1, that'd be over 1 plus 3. So that would be 8 plus 1, that's 9 all over 3 is equal to 12 plus 3. Something's wrong here. Let me take a look. Now it's a negative 2. Well, let's try it again. So I have 4 times a negative 2. That would be a negative 8. So 4 times, looking up here, I have 4 times a negative 2, that'd be a negative 8, plus 1. All over negative 2 plus 1, that's a negative 1. On the other side, I have 12, all over a negative 2 squared, that'd be 4, minus 1 is 3, plus 3. So over here I have let's see, I've got a negative 8 plus 1, that's a negative 7, all over negative 1, so that would be 7. Over here I have 4 plus 3, which would be 7, so that checks too, so both those are good. Okay, let's find the LCD of this. To do that, I'm going to have to factor this first, and instead of rewriting it, I'm just going to go ahead and write the factorization. So for this factor, I have x plus 4, and for the other one, I'm going to have 2 times x plus 4. And so the LCD of these two is going to be 2 times x plus 4. Okay, so let's go ahead and take and multiply both sides of this equation by that LCD. So I've got 2 times x plus 4 times the left side. It's minus 2. And I'm going to go ahead and factor the numerator on the right-hand side and denominator. So that's going to be 2. So that's going to be 2 times x plus 4 times what I have on this side, which will be the top part's going to factor into 2 times x plus 10. And the bottom is going to factor into 2 times x plus 4. Okay, so let's go ahead and multiply this LCD in. So you can see that this denominator has x plus 4. It's going to cancel with the x plus 4 that's multiplying in. So this is going to be 2 times x plus 7. And when the 2 times x plus 4 multiplies by the 2 on the other side of the minus, I will have minus 2 times x plus 4. Now on the other side, the LCD is the same as the denominator of the right-hand side, so that's going to cancel out there. So what I'm going to have is just what's left is 2 times x plus 10. So let's go ahead and simplify this. So I'm going to have 2 times 2 is 4. So I'm going to have 4x. 4 times plus 7 is plus 28. Over here, I've got 2 times 2 is 4. So a minus 4 times x, that would be a minus 4x. And a minus 4 times this plus 4, that's going to be equal to minus 4 times plus 4, it would be minus 16. The other side, I'm going to have 2x plus 20. Okay, so let's simplify this side. I have 4x minus 4x, that's going to be 0, and 28 minus 16, that's going to be 12, so this side is 12. The other side is going to be equal to 2x plus 20. So now I'm going to subtract 20 from both sides. So if I subtract 20 from both sides, I'm going to get a minus 8 is equal to 2x. A minus 4 is equal to x. Okay, so let's go ahead and try to check that. And what we're going to find out is if I put a negative 4 in here, you can see that my denominator is going to become 0. So this one's also going to be extraneous. And what I'm going to have is no solution. The last example is a special case of where I have irrational polynomials that are equal to each other, and so that's actually a proportion. Notice that I only have 2 terms. One's on one side of the equal to sign, the other's on the other, so I can do cross products. So if I do cross products on this, I have 2 times x minus 1 is equal to x squared minus x. So let's go ahead and multiply these out. That would be 2x minus 2 is equal to x squared minus x. Moving everything to one side, so this side would be 0. I would have x squared. And now I'm going to subtract 2x from both sides, so that's x squared minus 3x. And now then I'm going to add 2 to both sides, so that would be plus 2. So factoring that, I'm going to get x minus 2 times x minus 1 equal to 0. So x is equal to 2, x is equal to 1. Now let's check those. And so let's check 1. So if I put 1 in there, I'm going to get 2 all over 1 squared minus 1 is equal to 1 all over 1 minus 1. So 2 over 0 is equal to 1 over 0. And look, we're dividing by 0 in the denominator. That we cannot do that, so 1 doesn't work. That's going to be extraneous. Let's check 2. And that would be 2 all over 2 squared, which is 4. So I have 2 all over 4 minus 2 is equal to 1 over 2 minus 1 is 1. So I have 2 over 4 minus 2 is 2. It's equal to 1 over 1. 1 is equal to 1. That checks, so this is a good solution.